So for preview activity 3.1, we're given the graph for y equals h of x, and part A asks us to find all values of c for which h of c is a local maximum. So that means it's maximum relative to the points around us. So we might think of it as the peak of a mountain. So we have one here. So first value we see is at c equals -2. And then we have one up here. So also at 1. This one's not quite a peak because it starts back up again. And there's not a peak on this here. So those seem to be the only two values of c for which we have a local max. Now we're going to do a local min. Very similar, except now we're looking for a valley. Now looking at this graph, it looks like there's only one. And that's right here at c equals 0. Okay? Now, C. Does H have a global maximum? Well, that does because it has one value, one output that is higher than all the others. The value of the global maximum is going to be 2. Because now we're talking about the maximum value of the function, so it's the output. So the global max equals 2. And it occurs at 1. Now, D asks for a global minimum. Well, notice here our function just keeps going down at both ends. So there is no global min because it's going to go down to -infinity as far as what we can tell. So we would say the global min does not exist. E. Identify all values for c for which h prime equals 0. So this is looking for a horizontal tangent, and there's only a couple of them. We're going to have a horizontal tangent right here. It flattens out, and you can kind of see the horizontal tangent line. So that's going to be at -2.5. We're also going to have one here at our local max. We can see the horizontal tangent, the turning point. So that's at c equals 1. Now, we might think, oh, well, wait, we had a local min and a local max and a local min here as well, but the derivative is not actually 0 at that point. At those points, we actually have places where the derivative does not exist. So, because we have corner points. So that takes us to our next one, F. Determine all the points where the derivative does not determine all the points where the derivative does not exist. So we got one at -2. You see the corner point. We have one at 0, and there is one other corner point right here. Looks like it's at 1.5. So those are all inputs where the derivative of this function h is not going to exist. So let's look at our last couple questions. G, true or false? Every relative maximum and minimum of h occurs at a point where the derivative is 0 or does not exist. And that is true. Our local maxes and our local mins occurred at places where our derivative was either did not exist or was 0. Okay, and we're going to see that those are going to be called our critical values or our critical points. H. True or false? At every point where h prime of c is 0 or does not exist, h has a relative maximum or minimum. Derivative was 0 right here, right? And it was neither a max nor a min. Derivative didn't exist right here. Also, neither a max nor a min. So that's going to be false. So just because the derivative is 0 or does not exist does not mean we have a local max or a local min. We saw that the reverse is true. If we have a local max or a local min, then the derivative is either not going to exist at that point or be 0.